Differentiation. The process of differentiation establishes the slope of a function at a particular point. That can be said to be establishing the rate of change of the dependent variable with respect to the small change in the value of the independent variable. The derivative of a function measures its exact rate of change at a point. The derivative of y with respect to x is denoted, as you can see, dy dx, which is read as the derivative of y with respect to x, or dy dx. Simplified depreciation process. And we will majorly factor the power rule, which is the basic rule. So imagine you have been given the function of y is equals to 5x raised to power 3. Let 5 be the base, x, let's term it as the coefficient, then 3 to be the power. So the step that we shall simply use will be step number 1, multiply the base with the power. Then step number 2, less 1 from the power. So using our example above, we shall have the first step as 5 times 3 giving us 15. Then step number 2, 3 less 1, which shall be 2. Hence, our dy dx of y is equals to 5x power 3 shall be 15x raised to power 2. The second and very important rule that we shall use is the sum rule in differentiation. In this case, we shall have a function involving several segments. Like for example, let's imagine you have been given the function of y is equals to 8x raised to power 3 minus 0.5 x raised to power 6 plus 9x plus 40. We are going to follow the same steps of differentiation on each segment, but then retain the segment's sign. That is, we multiply the base with power and less 1 from the power of each segment independently. Hence, we can say the dy dx of our function of y is equals to 8x power 3 minus 0.5x raised to power 6 plus 9x plus 40 will be 24x raised to power 2, because we've had x times 3 giving us 24, then less 1 from 3 giving us 2. Therefore, 24x raised to power 2 minus 3x raised to power 5 because of 0.5 times 6, and then 6 less 1, which is 5. Therefore, 3x raised to power 6. The other segment we shall have plus 9. This is because in our original version of 9x, we are assuming that this x is raised to power 1. Therefore, we shall have the first step of multiplying base with power 1 times 9, which is 9. Then the second step of less 1 from the power, 1 minus 1 is 0. And remember, any value raised to power 0 is 1. So our 9 times x power 0 simply is like 9 times 1. Therefore, it's 9. Then finally, our value of 40, to differentiate, we are assuming x is raised to power 0. So if we go by our steps of multiply the base with power, we will first have 0 times 40. Any number multiplied by 0 is 0. Therefore, 40 after being differentiated becomes 0. That means our differentiated function will be 24x squared minus 3x power 5 plus 9. If I can summarize the last two parts, like we are saying in short, segments with coefficient raised to power 1 after differentiation just retain the base, like 9x differentiated becomes 9. And those without coefficient after being differentiated becomes 0. Like our value of 40 after being differentiated became 0. Application of differentiation. We want to understand the reason as to why we have been understanding these are particular rules of differentiating. And then we say, differentiation will be used during profit maximization. Importantly, an economic fact that will be of great significance that marginal revenue is equals to marginal costs at profit maximization. That means the reason as to why we have been learning differentiation is because to obtain marginal revenue, need to differentiate the total revenue function. Similarly, to obtain the marginal costs, differentiate the total cost function. Let's have our first illustration. And the problem is, a firm has analyzed their operating conditions, prices and costs, and has the following functions. Total revenue function is given by 400Q minus 4Q squared. Then the total costs function has been illustrated to be given by Q squared plus 10Q plus 30, where Q is the number of units sold. The firm wishes to maximize profits. Therefore, you are required to determine what quantity should be produced or sold for that matter. Then second, what would be the amount of maximum profits realized by the entity? The solution. We know very well that at profit maximization, which is what we want to get, the marginal revenue should be equal to marginal cost. Again, it is of our understanding that to obtain marginal revenue, got to differentiate the total revenue function. Similarly, to obtain marginal costs, got to differentiate the total cost function. Therefore, from differentiating our total revenue function according to the steps we have talked about before, our marginal revenue will be 400 minus 8Q. Again, our marginal costs, after differentiating the total cost function, we will realize it shall be 2Q plus 10. Therefore, our economic concept of equating MR and MC comes in, where we shall get a function of 400 minus 8Q should be equal to 2Q plus 10. Grouping like terms together, we shall move 10 to the first side. Crossing equal sign, it changes its sign to negative. Therefore, we shall have 400 minus 10 is equals to 8Q. We move it to the other side because of the like terms. Crossing equal sign, it changes to positive. Therefore, it shall be 8Q plus 2Q. Therefore, we shall now have 390 is equals to 10Q. Divide both sides by 10. We have 390 divided by 10 is equals to 10Q divided by 10. Finally, we shall get Q being equal to 39. Those are the quantities of units to be produced in order to maximize the profits. Remember, our concern was first the quantity to be sold to maximize profits. We've already got it, will be 39 units. Then secondly, we are tasked to determine what would be the amount of maximum profits. So hereby again we shall borrow an economic concept that profits are given by total revenue minus total cost. The whole thing is that we already have the total revenue function. Either way, we also have the total costs function. And because Q was representing the units, and we have the units as 39, we will move to the functions given, and at the point of Q, we replace with 39 so that we have a discrete value representing the total revenue and a discrete value representing the total cost. Upon doing the same on the total revenue, we shall realize the function becomes 400 multiplied by 39, which gives 15,600, less 4 multiplied to 39 squared, which gives 6,084, less 15,600 minus 6084 becomes 9,516, which is the total revenue. In the total cost function, we shall have 39 squared plus 10 times 39 plus 30, which gives 1521 plus 390 plus 30, which yields to 1,941, representing the total cost. And therefore, our maximum profits will be given by 9516 minus 1941, which sums to 75. That is 7,575, representing the maximum profits to be realized by the entity. So, ladies and gentlemen, not every question will be directly giving you the total revenue and the total cost for you to differentiate. Some of them will be giving a scenario that you have to elaborate by expansion of other economic concepts so as to arrive at the total revenue and the total cost. For instance, shall we check our second illustration? The problem is a manufacturer of television sets estimates that the average cost of making Q television sets is given by the average variable costs is 600 over Q plus 60, and the sales revenue per unit is given by R is equals to 200 minus 4Q. Then it requires you to find the number of television sets produced at break-even points and what is the possible maximum profit for the firm. Let us check the solution in this case. Now, we have been given the average revenue and the average cost. Economically, we know that total revenue through a function can be acquired by having the average revenue multiplied by the quantity of units produced or sold. Either way, the total cost can also be acquired by having the average variable costs multiplied by the quantity produced. So that means we will first determine the total revenue, which shall be given by our function of 200 minus 4Q multiplied by Q. That will give us 200Q minus 4Q squared. Then we get the total cost function by having a function of average variable costs, which is 600 over Q plus 60 multiplied by Q, which will give us 600 plus 60Q. So now with total revenue and the total cost functions, we can differentiate each to obtain marginal revenue and marginal costs respectively. That means our MR, arriving at it after differentiating our total revenue, shall be 200 minus 8Q. Then our marginal revenue after differentiating the total cost will be 60Q. From prior understanding, we already know that at maximum profits MR should be equal to MC. Therefore, 200 minus 8Q should be equal to 60. Grouping like terms together, we shall arrive at 200 minus 60 equated to 8Q. Therefore, Ladies and gentlemen, 140 is equivalent to 8Q. Divide both sides by 8, we shall have Q being equal to 17.5. Those are the units that will maximize profits. Finally, ladies and gentlemen, it is not always you shall be tasked in determining the Q to maximize profits. It can be further expanded to a point of determining other economic concepts. Like, for example, in our current problem, it wanted us first to determine the number of television sets at break-even point. There again, we borrow from economics a particular concept that tells us that at BEP, that is break-even points, the total revenue should be equal to total cost. And because we have already identified the total revenue function as 200Q minus 4Q squared and total costs as 600 plus 60, we will have to equate the two functions of total revenue and total costs, where we shall obtain a function whereby 0 is equated to 4Q squared minus 140Q plus 600. Keen observation from a mathematics point of view, we'll realize that this is a quadratic equation which needs to be solved in a quadratic method. Let's use a quadratic formulae in order to identify the value of Q in this case. And so by using the quadratic formulae, we identify the sections of A, B, and C. A is 4, B is negative 140, and C is 600. We fix the values in the quadratic formulae and solve either by use of a calculator or basically handling it mathematically. We shall realize X can either be 30 or can be 5. Those are the two different levels of Q where the firm will be at break even. That is no profits nor loss. Finally, ladies and gentlemen, the final task is to determine the possible maximum profit for the firm. And since we have already identified the number of items to be produced at maximization point of the firm, and we know very well that profit is given by total revenue less the total costs. Either way, we already have the function of total revenue, also the function of total costs. Allow me to give this one as a personal assessment to check if you're able to identify that specific final Q to maximize profits. Ladies and gentlemen, thank you for your participation in today's video regarding differentiation. May God bless you abundantly, even as you purpose to meet in our next video analyzing integration and its application in a business setup. May God bless us all.